My college algebra dogs is what we're going to go with this year. Today we're going to be looking at 1.1. All right. First thing we're going to talk about, I don't know if you guys ever heard of this, it's called order of operations. All right. Now, this does seem rudimentary. We haven't done it, or you're probably thinking I've done this since 7th grade. Go on Facebook, go on anything right now, and see how many times there's an order of operation problem done wrong by like 10 to 15 people, and they're all arguing because they know they're right and someone else is wrong. I'm going to let you in a secret. Most people are usually still wrong. Okay? So it's important. If we can't do PEMDAS, if we can't do order of operations, this is going to be an extremely long year, right? So it is PEMDAS. You guys have seen it, know it, love it. Now, I like to do that because I'm going to show you guys why a lot of people are wrong. I'm going to show you guys the change. So a lot of people, if you go online right now, are going to put multiplication ahead of division. And they're going to be like, well, everyone knows it's PEMDAS. You put multiplication ahead of division. But is it, let's say I did 3 times 9, right? That's the exact same thing as 3 divided by 1/9, right? These are the exact same problem. So can't I write any division problem as a multiplication? And I can write any multiplication as division. So are these actually 2 operations? No, they're the exact same operation, so they are equal. Please get off your laptop. All right. So addition, subtraction, same thing. 3 plus 1 is the same thing as 3. Well, 3 minus -1, right? They're the exact same thing. So is addition and subtraction 2 different operations? No, they are the same operation. So it shouldn't even be PEMDAS. These are just the same, and these are the same. So what do you do with multiplication division? Left to right if they're all in the same thing. Same thing with addition and subtraction. All right? We're halfway through lecture 1.1. So I'm going to throw up some examples. We're going to do them. There's no way that this is actually on camera right now. That's fine. It's the first video. It'll go on my eval. All right. Again, this is old school. You can use a calculator here. Graphing calculators are going to be what you want to use. Okay. Order of operations. What do you guys want to do first? Parentheses. Then what do I do? Exponents. And 2 to the third is 8. Then my multiply, divide. Then my add, subtract. Again, I know I'm going to go through this first part really quick. Some of you might be thinking, why are we doing this in a college class? Trust me, when we get to like our quadratics and conic sections at the end, this is what destroys most people, is they just forget to follow their order of operations. All right? Here's my next quick reminder for you guys. All right. Parentheses first. Of course, of course. What's -6 squared? I disagree. It's -36 because that negative, there's no parentheses. So what do I do first? The exponent. So 6 squared is 36. The negative I'm treating like a subtraction, right? Because the negative's not in parentheses. It's not part of the exponent. All right, so -36 plus 8, I don't know, it was -28. Okay? Again, another just common mistake. This will help you out too come SAT time. What makes this problem different than This one. It's going to be positive 36 because that whole thing's being taken to an exponent. Oh, wait, and I wrote the problem differently. So I do my parentheses. Now this whole negative 6 is part of the exponent. So negative 6 times negative 6 is positive 36. $44. Sound good? Anything too scary? Perfect. This whole clock change thing is going to really throw me off for when class ends. I don't even know what time class ends. All right, I'm going to do one more example. What if I do this? All right, how many actual different operations do I have on that problem? One, because what's subtraction but adding a negative? So I'm going to read this like a book, left to right, and just start going through. 14 minus 6 is 8. All right, I'm not going to. 8 plus 3 is, you don't have to show all these steps. I'm just showing you my left to right prowess. 14. Any questions, comments, and or concerns? All right. So that's probably one of the most important things to know in all mathematics. And the thing we're going to use the most is going to be called evaluating or evaluate an expression. All right. So I know with this being college algebra, some of y'all are here because you have to take a math class in college and now you're going to be done. Some of y'all are here because you might be looking at some sort of math career and you want to get started. Doesn't matter where you go in math, this is probably the most used thing we're going to do. Okay? What's the common term for evaluating expression? Plug in stuff. That's the technical term. We're going to plug in stuff, right? What's one thing that we got to remember when we're plugging in stuff? When we plug in stuff, don't tell English teachers I'm saying stuff, please. Plug in things and stuff. You have to use parentheses, right? If you have your calculator and you're plugging in different things, use that parentheses key. Okay, use lots of parentheses. Because that'll make sure that your operations are going to be followed more correctly. All right. Let's evaluate. Oh, this can be wild. 3x minus 2 when x equals 4. All right. So we're using the good old-fashioned substitution property. X is 4. Wherever I see an x, I can plug in a 4. And when I plug it in, I'm going to use parentheses. Ta-da. All right. So let's evaluate. Let's try a different one. Let's do 2x to the third minus y. When x equals 3 and y equals 9. Sound good? So all I'm going to do is plug in a 3 plug in a 9. So I'm going to do 2 times 3 to the third minus 9. Do you have to put parentheses around it when you're adding subtracting? Nah, but it won't hurt me to do it. So now I got to use my PEMDAS. 3 to the third is 27. Right there anyway. Minus 9. So it's at 54 minus 9. 2 times 27. 45, like how old I feel. Actually, I'm pretty close to. Doesn't work anymore as a joke. All right, so that's another type notation. Now I'm going to throw out a new notation. Are we good so far? All right. All right, let's do. Let's say I have x of 1 plus 3, x of 2 squared minus 4. I have a subscript and a superscript. When x of 1 is 4 and x of 2 is negative 3. I know it. All right. I think it's a programming thing for some things. Like if you want to stay, if it's something that is being affected 2 ways on the x-axis, not on the y. Does that make sense? Oh. Because, is that better? Yeah, tutoring can help you. All right. Yep, remember if you get stuck, tutor.com. It's probably better than I am. All right. So I'm going to plug in 4 for my x1. I'm going to plug in negative 3 for my x2. All right. So 4 plus 3 is 7. Negative 3 squared is positive 9, right? In the parentheses. That's 7 over 5. Now, when you go to Moodle and do it, it's going to ask you for decimals. It'll say what place to round to because it's not great with fractions. If you end up moving further and further in math, fractions are always really good. But I mean, this one's actually a really nice fraction. Was it 1.4? Both are fine answers. I just don't like rounding. Once you get to like pre-calc and calc, rounding is not good. Not good. All right, there we go. That was the first chapter or first section. We did it. I told you it's gonna be fast and furious. You guys scared yet? That's fine. What? All right. 1.2. Real numbers. Order of operations and evaluating. 1 point fun is 1.1, but 1 point fun. All right. This one's actually, if we could start at 2.1, that'd be amazing. All right. Natural numbers. This is going to be the naming of numbers. This will be like the third time some of you guys have seen this. Remember, there's different types of numbers. We have the natural numbers. These are the ones that don't use tren. That's a type of steroid for those of you guys who don't know. Obviously, I don't know. All right, natural numbers are going to be 1, 2, 3. They're going to be numbers that don't have a decimal. They don't include 0. They're also called the counting numbers because it's how we count. You don't go around counting and start with 0, do you? If you do, that's okay. That's I guess your choice. But you don't be like, all right, how many fingers a guy got? 0, 1, 2, 3. Actually, fun fact. So natural numbers were the first numbers that existed, right? Because like we use the Arabic number system. It was used for money, right? To say instead of having to bring your cows every time to trade, they invent coins and numbers to be like, I have this coin represents 3 cows, So you have to bring, I'll give you the coin, you can come get the cows. So that way, if I went and I didn't sell any of my cows, I didn't have to like just make a few days journey, bring them to market, and then come back. I would just bring my coins that represented it. 0 wouldn't exist because I wouldn't have a coin that says 0. Why would you be walking around with a 0 coin? You know what I mean? So that's why these are the natural numbers. So then later they came up with the whole. Emphasis on the O. Whole numbers. These are your natural numbers plus 0. I don't have a good story for that one. They just said, hey, 0 should be a thing. Isn't it funny? There's like hundreds of years where just 0 didn't exist. They didn't look at my bank account, I guess. All right, so integers. So integers are your whole numbers plus negatives, right? Like -3. This is when banks came into existence and debt was a thing. That's not true, but it's a good joke. Maybe it's not a good joke, but it is a joke. But yeah, this is negative. All right. I'll be honest, you do have a few questions on homework like this. I think there's 1 or 2 on the quiz test, but it's not going to come up a whole lot. What is going to be more important is knowing the difference between a rational I should have put, I use that R symbol. It's actually an R with a little thing. Integers are Z, if you're curious. Whole numbers is like a whole different letter. Just don't use it. So these are, if you want to get into theory, they're written as P over Q. They can be written as a fraction of 2 things. Because they can be written as a fraction, they include natural numbers, right? Because 2 is 2 over 1. They include whole numbers. It could be 0 over 5. Integers, -3 is -3 over 1. But I'm also going to include things like, 1/2, 5, 6.2, 0.3 repeating. So you're including your repeating decimals, your ending decimals, I gotta get rid of this. Get out of here. What about 0.12567.5? Yeah, so why is that a rational number if it's some long decimal? Can you rewrite that as a fraction? Yeah. What's that? 1, 0, 0, 0, 0. There you go. I wrote it as a fraction. So terminating decimals, repeating decimals, and then your integers, right? So those are all rational. What about irrational? All right, so rational numbers cannot be written as a fraction. So these are going to be things, think about non-repeating decimals is pretty much what it comes down to. Everything else is going to be rational. So like square root of 2. Doesn't repeat, goes on forever. There's a number called E that we'll deal with later. Pi. Pi is the most interesting irrational number that ever existed because pi is circumference over diameter. So how do you find pi? By dividing 2 numbers. That's the most wild thing to me, that is irrational. All right. Now, all of these are real, right? All of these are real numbers. So later we're going to talk about complex. Complex numbers are not real. And that's pretty much going to be square root negative 1, which is I. We're going to talk about that. I'm sure you guys talked about that in Algebra 2 at some point, complex numbers. We will hit on these in like 2 units. But yeah, that's my chart. Perfect. Yeah, let's do a few examples. So I love examples to get you ready for the homework set. Are we good? Can I erase this? All right. So you guys have the chart. Oh, that's what I need to show. So let's talk about something interesting about all real numbers. All real numbers can be graphed, right? What I mean by that is if I make a number line, they will exist somewhere on the number line. I completely forgot. I do have to teach you guys number line. I think we do it. Anything to the left, I'm going in the negative direction. As I go to the right, I'm going in the positive direction, right? Right is positive, left is negative. All right. Let's talk about number 4. Can I plot number 4? Yeah. I can put a dot in number 4. So what kind of number is number 4? Is it irrational? No. Is it rational? Yeah. Can you write number 4 as a fraction? Yeah. Is it an integer? Yeah. Is it a whole number? Yeah. Is it a counting number? Can I count it on my fingers? Yeah. There we go. All right. What about negative 5? So when I look at my chart, it's not decimal, so that already tells me it's going to be rational. Again, not decimal at all, so I know it's going to be an integer. Now, it's negative, so is it a whole number? Nope. And once you stop on the chart, you're done, right? If you're not a whole number, can you be a natural number? No. If you're not an integer, can you be a whole or a natural? No. If you're not rational, can you be any of these? No. So it's pretty much, if you're a natural number, you're all of these, right? But not all rational numbers are natty. All right, let's do, what about 1/2? 1/2 is a fraction. So it'd be a decimal that terminates, comes to an end, so it's rational. Is it an integer? Nope, so I'm done. There's no other way to classify it. What about pi? So my first question is it rational or irrational? It's irrational. Once you're irrational, there's nowhere else to go. Like in real life. Once you're irrational, you're done. There's no other subcategories of them. All right. Let's do one more. What about, actually, we'll throw a trick. What about square root of 9? Oh, it's a square root, so it's automatically irrational, right? No, what? I tried. Can you simplify it first? Yeah. So that's going to be the same as 4, right? Rational, integer, whole, natural. All right. That's all I got for you guys. That's 1-1 and 1-2. We went through all of chapter 1. We're done.